Okay, guys, here goes another free response problem. It's 2018, problem number 4. It's another one we did before. So I start the problem. I see a table up here, times in years. H, which is the height of the tree, is in meters. Okay, the data is not regular. There's one between those. There's 2 between that, 2 between that, 3 between that. Okay, let's see what it's all about. The height of a tree at time t is given by a twice differentiable function h. Okay, so twice differentiable, they always like that, remember? That means there's no craziness going on. It's a very well-behaved function, okay? Hang on a second, guys. I'm going to try and change this height. There, I got them both involved. So where h of t is measured in, you know what is up better? Yeah, let's go back to this. Okay. So h is measured in meters, t is in years. Selected values of h and t are given in the table, all right? So use the data in the table, tell me where to go. Estimate h prime. H prime is the rate of change. It's a derivative, okay? It's the change in h over t, and I got h and t in this table. Using correct units, interpret the meaning of h prime of 6 in the context of the problem, okay? So guys, that's a rate of change using the table, okay? Guys, it's algebra 1, okay? Algebra 1. That's an easy one, okay? So A. You know what? I'm still not liking this height. All right, that's a little bit better. Okay, so guys, I need h prime of 6, okay? H prime of 6. And in the table, I've got, so I want 6. I don't got 6, but I got times at 5 and 7. So you remember algebra 1. I'm going to do h of 7 minus h of 5 over 7 minus 5. Okay, 7 minus 5. And if I look in the table, I can see that h of 7 is 11, h of 5 is 6 over 2, so I get 5 halves. So h prime of 6, h prime of 6 is the rate of change in tree height, rate of change of tree height in meters per year when time equals 6 years. So guys, they're looking for 2 things there. They want h prime of 6, which is 5 halves, and they also want you to tell them, what does it say? Interpret the meaning. All right. So that's part A. All right. Part B. Part B. Explain why there must be at least one time. Guys, when you start seeing things like at least one, explain why there must be at least one, they're usually talking about one of the theorems, okay? And the most likely theorem is the mean value theorem, okay? The mean value theorem. So they want to explain why there must be at least one time between 2 and 10. And if you look at the table goes between 2 and 10, such that h prime of t equals 2, okay? So if you remember B, okay? Remember B, we need to prove the mean value theorem holds. That's what we're doing, okay? So if you remember, there's 3 things for the mean value theorem that have to, okay? 1, need to be continuous on the interval. It's got to be continuous on the interval. 2, need to be differentiable. So guys, you're going to want to have the mean value theorem access to you on the exam day. Have it on a piece of paper in front of you. So you got to be continuous on the interval, and you got to be differentiable on the interval. Okay, guys, remember, if you're differentiable, you're continuous. Being continuous doesn't guarantee differentiability, because remember, like the absolute value function, that's a continuous function, but it's not differentiable because the derivative changes very quickly at that point. So you got to be continuous and differentiable. Well, if you remember, I told you it was twice differentiable. Okay, so since h of t is twice differentiable, so it's twice differentiable over the interval, it is continuous and differentiable. Okay, so you 2/3 of the way through the mean value theorem. Okay, the last part of the mean value theorem says that let's see, they want to prove that h prime of c equals 2. So they want to find some time in the interval. And what's the interval they're talking about? 2 to 5. So there's got to be somewhere where where the slope of the secant equals 2. Okay, guys, I'm going to switch to another piece of paper here. Okay, so if I look at the table, and this would enable me to kind of look at the table here. So guys, if you look at the table, you need somewhere where delta H, so what you're looking for delta H over delta T equal to 2 somewhere in the table. Okay, so sometimes they make it nice where it's the last minus the first. So 15 minus 1.5 is 13.5 over 8. That's not equal to 2. So then I'd look, okay, what about 11 minus 2? That's 9 over 6. I'm sorry, 9 over 4. 11 minus 2 is 9. 7 minus 3 is 4. So 9 over 4, not quite there. Let me see. Let me just look these two. 11 minus 6, 5 over 2. No. What about here? 6 minus 2 is 4. Oh, yeah, that works, guys. So look. Let's see. H5 minus H3 over 5 minus 3 equals 2, which equals H prime of C. Now, guys, you have to say this. Therefore, by the MVT, there exists a time t between 3 and 5. So where h prime of t equals 2. So guys, you got to say that it's the mean value theorem that enables you to say that. So you're showing that the 3 conditions of the mean value theorem hold. Okay, part C. Use a trapezoidal sum. So guys, they're telling you what to do. If you know what a trapezoidal sum is, this is a gift. With 4 subintervals. Look, 1, 2, 3, 4. There's 4 subintervals. Let's see. To approximate the average height of the tree over the interval from 2 to 10. Okay, so guys, you don't know what average height means. That's not something that's in this year's test, but I figured I'd at least show you how to do a trapezoidal sum. So, guys, this is what you're looking to do. What? Part C. Okay, so average height means 1, you divide by the interval length. So it's the integral from 2 to 10 of h of t dt. And they're looking to do a trapezoidal sum. So it's 1/8 times. Guys, to do the trapezoidal sum, if you remember, you just add the y's find the average of the y's, divide by the delta x. Average of the y's, divide by delta x. Average of the y, divide by delta x. I'm running a little bit low on time here, so I'm good. Okay, guys, you get this. If you add it all together, you get 1/8, 65.75. And that would be good for the answer. Okay, guys, part D. All right, part D. The height of the tree in meters can also be modified by this function. Okay, so the table's gone. We're just dealing with this function, where x is the diameter of the base of the tree in meters. So when the tree is 50 meters tall, okay, so that's telling you when g is 50 meters. So when g of x equals 50, the diameter of the base of the tree is increasing at the rate of 0.03 meters per year. So guys, that's dx over dt, okay? So dx over dt is 0.03 meters per year. G of x is 50. According to this model, what is the rate of change of the height? Rate of change of the height, that's dg over dt, because g is the height of the tree, with respect to time in meters per year at the time when the tree is 50 meters tall. Okay? So guys, that is a related rates problem. Okay? So we're going to need to do related rates. All right? So here we go. D. You know what, guys? I'm afraid this video is getting too long and it's not going to let me post it, so I'm going to do D in a separate video.